Hi, everybody. I want to give you some ideas for your um, Coral project. Right, so I'll update you quite regularly. And so this is just some things when you go out and you look for papers or you look for newspaper articles to help you write on. Remember, you're taking in a lot of environmental aspects when you talk about the destruction of a coral reef or how humans can impact a coral reef. So, for example, in this one right here, you have failed septic systems, right? So that means there's a leak in a line, and there's organic waste that can cause algae blooms, right? Algae will block the sun, and they will remove oxygen from water. And there's also bacteria that comes out with that, and that can be highly toxic to the coral or to other species that live there. Sunscreen is a big thing. So if you type in on Google sunscreen, coral reef, you'll find out that there's places all around the world that have outlawed sunscreen on the beaches near coral reefs. Key West recently did that. They outlawed it, and then for whatever reason, the city council brought it back. I guess somebody got paid off. Who knows? Coastal development. A good example might be there's an area where there's lots and lots of mangroves that serves as a great buffer between the land and the ocean. And in those mangroves lives all sorts of fish larvae. Small fish when they're young. It gives them a place where they can hide right from predators. And so if you come in and someone's going to build a whole bunch of condos and they cut that mangroves down, suddenly there's no habitat for those fish, and now suddenly there's less fish. It also serves as a buffer for runoff, right? So if you have a huge mangrove swamp there between a small town and a coral reef, right, it's going to buffer some of the runoff there. Once that's gone, and say it's just sand, you're out of luck. Stormwater runoff, right? So under cities, right, lots of pipes carry, water, and they dump it into, canals, into bays that ends up in the ocean. And who knows what's in there? Depends upon where you are. But there can be more motor oil and gasoline on the road. There can be paint. There's all sorts of things that can be out there that when you get a heavy rain, it gets herbicides and pesticides. It gets washed out to sea. So those are a whole bunch of topics you can look at. Deforestation, right? You cut down a forest, you suddenly have a whole bunch of dirt that's bare. And now that's when you have a heavy rain, a lot of that's going to end up in the ocean, right? So if you're in an area, for example, that has clay, right? Clay can be acidic. It has a lot of heavy metals in it, right? And that's just not good for any kind of marine life. Oil and chemical spills, right? And that could be anything from fires to just the fact you have a whole bunch of hydrocarbons in the water that's no good, that will just coat things and kill it. Road construction, right? A lot of times you'll see them put those yellow bumpers out that try to minimize sedimentation. But again, if you get heavy rain, you're going to get a lot of dirt that blocks the sun, covers the corals. It might impact other species that are there. In agriculture, one of the big things is nitrate and phosphate, right? That's the two key ingredients in fertilizers. So, for example, in Florida, in the Everglades, they have a lot of sugar cane. A gazillion acres of it, and it flows down into what's called Florida Bay and hits the coral reefs off the Florida Keys. And that causes a tremendous amount of algae blooms. Algae blooms can literally just basically be a green blanket on top of a coral reef, blocks the sun, right? And you remember the zooxanthecan, right? The symbiotic microbe that's within coral suddenly doesn't have sunlight and it dies. So that's one example. Just to give an example, because a lot of you will, it depends on where you are, but this is an algae bloom off the coast of England, right? And it's taken obviously with a satellite, but these things can be huge, right? So it's not just 50 feet by 20 feet. They can be 50 miles by 20 miles, right? They can be tremendous in size. And so if you have any rivers or cities nearby, and they typically come from when you have a lot of heavy farming right near the ocean, and that the nitrates and phosphates, they don't do anything to block it from entering the waterways, entering a river or stream that enters into the ocean. So again, that gives you your algae blooms, which throws the rest of the ecosystem off. So that's something to look for. Remember we went through coral diseases, right? Those black banded, white banded, right? There's a number of them. You can again go on to Google, type in coral diseases, type. And so what happens is the symbiotic microbe that lives within coral gets knocked out, And so remember, the coral can still live after that, but its lifespan is going to be pretty short, so it has to bounce back. But coral bleaching is something that probably every one of you should be able to find something on with your particular reef, right? Now, if you have a reef, for example, Koshi, we saw some of her stuff, has Molasses Reef in the Florida Keys. Maybe she can't find something on Molasses Reef, but she can find something on one of the other reefs that's in the Florida Keys that's nearby. That's fine. Okay, try to focus on your reef, but if you have to span out a little bit to, a nearby reef, that's fine also. Okay, so some other things to think about, right, is other types of more water activity. So, for example, fishing. When fishermen drag nets along the bottom, right, they go and they drag, and for example, in shrimping operations will do this, and they do it in Florida. And what they can do is they just, everything that's down there, it could be sea turtles, it could be corals, it could be sponges, they all get pulled up in that net, okay? And the term for that is bycatch, B-Y-C-A-T-C-H, bycatch, because they're after shrimp, but they catch everything, and when they pull it up, everything's dead, okay? And so that's one example, right? Just regular fishing, and I'm not talking about, two guys out in a boat catching, 6 bluefish. I'm talking about commercial fishermen can come in, these big ships that come in, not just in the U.S., but they'll come to the U.S., or off the, coral reefs around the world from Japan, from Russia, from China, right? And they pull up, a gazillion tons of fish, right? And that can damage the ecosystem tremendously. Divers can have an impact, right? And I'll give you a couple examples. One is they'll go down and just touch corals. When you touch a coral, you can kill it. And so you can go to coral reefs, like in the Florida Keys, where the whole coral reef is dead because they've dropped so many people there. Another thing that people will do is they, like say, for example, in lobster season, they'll go down, get a bottle of Clorox, go underwater, and the lobsters like to hide in holes. So they'll stick their bottle into the hole, blast it with Clorox, the lobster comes out and they can grab them. You say, okay, what's bad with that? Well, that Clorox is in the ocean. It's moving. And so they might white out or kill basically a 10-foot area of the coral reef just to get that one lobster, right? Doesn't make much sense. And then you have things like traps, right? So traps can catch all sorts of life that live on the reef, right? And if you do it every once in a while, it's okay. You start doing a lot, like you have in the Florida Keys, where you have thousands of lobster traps out there. You can really decimate it. But it's also sometimes where they throw the lobster traps, right? They can throw them right on top of a reef and kill stuff. And then a lot of times you have the boats going near the coral reef, because coral sometimes can be very shallow water, and having a boat bump against it is not a good thing, right? It basically kills it instantly. Okay? And so this next one is one that I handed out, right, in class. Right, and so remember, there's the big thing. So we just talked about, like, some of the smaller, human-based activities, but there's massive things that, a few people can't change. One is the slight increase of temperature of the ocean. So you should be able to find some journal articles about your reef and that. Next thing is sea level rise. You probably will not find a tremendous amount about that, but if you do, that's great. Storm patterns, right? So remember, coral reefs formed over thousands of years, okay? And so when you have storms that typically come in at a certain area from a certain direction, the corals have adjusted to that as the reef has been built up over thousands of years. But now if that current is now coming in from a different angle, it can completely devastate a reef, okay? Changes in precipitation, what that does is, remember when it rains on land, that flows into the sea and it changes the salinity. So if you have more or less rain, that's going to change the salinity of the reef. So just as an example, off the coast of Miami, there's coral reefs, right? And they're just 2 miles offshore or 3 miles offshore. So if the Everglades is not pouring as much water with the nutrients in it out to sea naturally, then that can impact the reef. And then the last one, everyone should probably have a few pages on, is ocean acidification. Because remember, corals are made of calcium carbonate, right? And carbonate reacts with acid to make carbon dioxide, right? So that reaction should be in there. That's an important one. Okay? And my guess is that most of you will be able to find some specific species that somebody has studied on your reef or nearby, right? So if you have, say, the Florida Keys, there might be 20 or 30 different types of corals. Nobody went in and studied the impact of ocean acidification on all 30 types of corals that are there. They picked one or two, and that's what they're looking at, a small patch. They went back to it over and over and over again and examined its impact. So that's an important one, right? And you should have some chemical equations with it. So remember, ocean acidification, the reaction, it starts with carbon dioxide, right? And carbon dioxide absorbs into the water and it becomes carbonate, right? That's a normal process. I shouldn't say normal, it's a natural process at low levels. Since we burn so much stuff, it's not a natural process. Okay, and so you might find something on a specific species that lives on your reef, for example, in this case, damselfish, and the impact that ocean acidifications have on it. So remember, typically things with shells, snails, lobsters, crabs, corals, you'll find papers on that because the ocean can dissolve that mineral. Okay, so remember, all these things are tied together, right? And so you may talk a little bit about a fisherman, and they're throwing nets over a coral reef and ripping it up, but that's not the only thing that's happening, right? There can be, land use, right? Biodiversity loss, freshwater use, right? So if freshwater pours into a certain area and it brings nutrients with it, right? If there's a swamp like the Everglades, and that fresh water carries carbon, that's natural nutrients for the reef, and that's suddenly shut off, it's going to impact it, right? You have the different cycles. Phosphorus is important, right? The nitrogen cycle is important. The carbon cycle is important, right? So you may work a cycle into your paper, right? And you'll find all sorts of stuff. When you put in images, okay, if it's something like, here's a picture of a coral dying, that should be the original image. Be sure you cite it. But if you have something like a cycle, do the cycle again, but make it in a power. You can make it with word art, right, in 2 dimensions. Ozone depletion, right? That's up in the atmosphere. You absorb light. It absorbs UV. When the ozone's not there, that means more UV's hitting the surface, so things heat up. It causes more cancers and things like that. Okay, so you can take a bigger look at it also. All right. And so on that note, I'm going to let you get back to work. Don't forget, the last part of your paper should be journal articles and newspaper articles, but you shouldn't have, Bill's, big page of coral stuff. You want to have things that are credibly referenced and follow an APA format. Remember, I sent everyone an email with the details of how it should look. So, and something like this, you want to build with time. If you do it in the last 2 days, it's going to look really bad, okay? But you want to go through, follow it, and slowly build it up to a page or 2 a day. You'll learn a lot from it. You'll learn a lot about the world you live in, right? So, corals are like what they call a canary in a coal mine. When people used to work in coal mines and they didn't have technology, they used to bring birds into the coal mines with them, right? And then if they hit bad gas that they couldn't smell, like methane, they couldn't smell it, the canary would die. And so they knew it was time to get out, right? So there's a lot of little canaries in the coal mine type of scenarios that take place on the coral reef that impact the rest of the planet. Okay, and I'm going to post this on YouTube, and I will be in touch. Thank you very much.